And now to the last part of our discussion on motion along a straight line. Last part of our kinematics topic, we have projectile motion. Whenever you throw an object, say a basketball, whenever you throw a basketball diagonally upward, or horizontally or diagonally downward, the resulting motion of the object is referred to as projectile motion. Put in simple terms, projectile motion is basically freefall motion combined with uniform motion. That is to say, the x component of the object's motion is considered uniform motion, whereas the y component of the object's motion is freefall motion. Since the variables of our kinematics, displacement, velocity, acceleration, they are all vector quantities, we can divide these variables, we divide the resulting motion of the object or the projectile into its x and y components. So for instance, you have the object thrown diagonally downwards. The resulting motion is projectile motion. You can divide the velocity of the object into its x and y component. The same goes for the acceleration of the object. You can divide the acceleration of the object into its x and y component. And finally, you can do the same for the object's displacement. We can divide the object's displacement into x and y component. And when we look at the x component of the motion on the x component is undergoing uniform motion. The acceleration ax is 0. The velocity of the object along the x-axis, along the x component, is constant, just equal to delta x over delta t. If you look at the y component of the motion of the object, you can think of it as tracking the motion of the object along the y-axis. The motion is freefall motion. Acceleration along the y-axis is just equal to acceleration due to gravity, which is constant for any location. And again, default situation for this course, location is on or near the surface of the Earth, where vector g is equal to negative 9.8 meters per second squared. And freefall motion is uniform acceleration. So we have 4 equations that we can use to analyze the y component of the motion of the projectile. You have Vy is equal to Vy initial plus Gt. Y is equal to Vy initial t plus 1/2 Gt squared. Vy squared is equal to Vy initial squared plus 2Gy. And then average velocity on the y component is equal to Vy plus Vy initial divided by 2 is equal to delta y divided by delta t. And you analyze the x components separately from the y component, bearing in mind that there's only one object moving. So for instance, there's only one time of travel. 5 seconds on the x component means 5 seconds also on the y component. So we can unite the two components, the analysis of the two components, using time t. So again, when you are presented a projectile motion problem, just divide the motion of the object into x and y component. analyze the x component separately from the y component, and then just unite the two analyses using time t. For instance, consider the following examples. Let's have sample problem 1. You have two buildings, building 1, building 2. From the roof of one building, a man throws an apple with a speed of 15 meters per second at an angle of 30 degrees above the horizontal. The apple will undergo projectile motion and lands on a balcony of the second building. The balcony is 10 meters below the roof of the first building. How far apart are the two buildings? The object, the apple, has been thrown diagonally upwards. The object will undergo projectile motion, so divide the variables of the motion of the object into x and y component. The acceleration on the x component is 0 because projectile motion along the x component is uniform motion. Automatically, the acceleration is 0, whereas the motion of the object along the y-axis, along the y-component, ay, the acceleration, the motion rather of the object along the y-component is freefall motion. So ay is just equal to acceleration due to gravity, negative 9.8 meters per second squared. Displacement along the x component is just d, positive d because positive direction, the displacement x on the x component. Whereas along the y component, the displacement of the object is, so the projectile, the apple, will go up and then down. The overall displacement from initial to final position is vertically downwards along the y component. Of course, the overall displacement of the object is diagonal, but if you look at the y component, it's simply going down vertically downwards. So 10 meters vertically downwards, y is equal to negative 10 meters. So we've divided the acceleration, the position, or the displacement rather, into x and y component. We do the same thing with velocity. We know the initial velocity, the initial speed is 15 meters per second, and then the direction of the initial velocity is 30 degrees above the horizontal. So we divide that into x and y component. Velocity along the x component, uniform motion, constant. So Vx is just equal to V naught, 15 meters per second, times cosine 30 degrees. Whereas, if you use your component method to divide the V naught into its y component is opposite the 30 degrees. So we use sine 30 degrees. Sine 30 degrees is equal to opposite over hypotenuse. Opposite is the y component. Vy initial is equal to the hypotenuse, 15 meters per second, multiplied by sine 30 degrees. Again, Vy initial because the object is undergoing freefall motion along the y component. So the velocity along the y component is changing. So this is just the initial velocity. Whereas On the x component, the object is undergoing uniform motion, so the velocity is constant. So even though this is v naught, initial velocity, on the x component, you just have vx is equal to constant. Analyze the motion of the object, the projectile motion, by looking at the x component and at the y component. Analyze each component separately. Let's start with the x component. Again, x component, uniform motion, so Vx is constant. Vx is just equal to x divided by time. Isolate time, t is equal to x over v is equal to d over 15 cosine 30 degrees. We do this because after analyzing the y component, we will unite the two analyses using time t. So in preparation for that, we isolated time t in the x component, and then we move on to the y component. Y component, we have freefall motion on the y component. Freefall motion, you have 4 equations to choose from, that you can analyze the motion of the object along the y component. One equation is y is equal to vy initial t plus 1/2 gt squared. Y is negative 10 meters. Vy initial is 15 sine 30 degrees. Ay is just acceleration due to gravity. So g, or negative g, negative 9.8 meters per second squared. And we have the equation for t is equal to d over 15 cosine 30 degrees. Using all that into the equation y is equal to vyt plus 1/2 gt squared, we get negative 10 is equal to 15d sine 30 divided by 15 cosine 30 minus 4.9d squared over square of 15 cosine 30 degrees. Simplifying the equation, we get an equation in terms of d, 0.029037703 d squared minus 0.5773502 d minus 10 is equal to 0. We have a quadratic equation in terms of d. Using quadratic formula, quadratic solution, we get two answers for d. D1 is 30.9944927 meters, and D2 will turn out to be negative. Since distance cannot be negative, we can ignore D2. The final answer, D1, distance between the two buildings, D is equal to 30.994 meters. Thus, we get the distance between the two buildings. How far apart are the two buildings? So again, divide the motion of the projectile, divide the variables into x and y component, and then analyze the x component separately from the y component. Unite the two analyses using time t to get the answer that you are required to get. Moving now to sample problem 2. You have a coin sliding on a horizontal tabletop. It slides off the tabletop with a speed of 5 meters per second. It undergoes projectile motion and lands on a plate on the floor. The plate is 2 meters from the foot of the table. What is the height h of the table? So once again, projectile motion, divide the variables of the motion into x and y component. Projectile motion, motion along the x component, again, uniform motion, automatically acceleration ax is equal to 0. Along the y component, motion is free fall motion, acceleration ay is just equal to acceleration due to gravity, negative 9.8 meters per second squared. Displacement along the horizontal motion is 2 meters. To consult the figure. And so positive direction to the right. So positive 2 meters is equal to x. Whereas the displacement along the y-axis is downward, equal to negative h. The coin is sliding on the horizontal table. So when it slides off the table, the velocity of the coin is horizontal. So all of v naught, 5 meters per second, all of that is in the x component, positive direction. So Vx is equal to 5 meters per second. And since you have uniform motion on the x component, the Vx is equal to constant. Since horizontal yung initial velocity, the y component of the initial velocity, Vy naught, is 0. And we are being asked to get the height h of the table. So once again, after dividing the motion of the object into x and y component, after dividing the variables into x and y component, analyze the x component, analyze the y component, and then use time t to unite the two analyses. So starting with the x component, Vx is constant, therefore Vx is just equal to x over t, uniform motion. Isolating t, t is equal to x over Vx. We know x, 2 meters. We know Vx, 5 meters per second. So it's just 2 divided by 4. We are able to calculate the time. T is equal to 0.4 seconds. Going now to the y component. Again, y component, you have uniform acceleration, free fall motion. You have 4 equations to choose from. Once again, looking at the equation y is equal to Vy initial t plus 1/2 gt squared. Okay, squared. 1/2 gt squared. The only unknown is h. Plot in the values, and you'll be able to calculate h to be 0.784 meters. And that's it for our discussion of projectile motion. That's it for our discussion of the topic of motion along a straight line or kinematics. So thank you for watching.